Hello students, welcome to our YouTube channel Experience Tutor. Today we'll discuss class 11th physics motion in a plane chapter 4 ncert solution part 2. Our mission is to provide free classes on YouTube for all the students of class 6 to class 12 and the students who are preparing for IIT, JEE, NEET, NDA and other competitive examinations. Before we begin, we request you to subscribe, like, and share our channel with your friends and among your relatives. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Let us begin the lesson. So, in the last session we have done till 4.10. Today we'll start with 4.11. A passenger arriving in a new town wishes to go to the station to a hotel. From the station to a hotel located 10 kilometers away on a straight road from the station. A dishonest cabman takes him along a citrus path 23 kilometers long, reaches the hotel in 28 minutes. What is A, the average speed of the taxi? B, the magnitude of the average velocity? Are the two equal? So according to the question, distance traveled, total distance traveled is 23 kilometer. Total time taken is equal to 28 minutes. What we have done, that 28 minutes we have converted to hour by dividing by 60, because 60 minutes is equal to 1 hour. So average speed of the taxi is equal to total distance traveled upon total time taken. Total distance traveled is 23. Total time taken is 28 upon 60, and the answer is 49.29 km per hour. Next part of the solution is distance between the hotel and station. The actual distance is 10 km, which is equal to displacement of the car. Average velocity is equal to displacement upon time taken. That is equal to 10 upon 28 upon 60 is equal to 21.43 km per hour. Therefore, the total physical quantity, therefore the two physical quantity, average speed and average velocities, are not equal. Now let us do question 4.12, or it will be better if we mark with red. 4.12. So rain is falling vertically with a speed of 30 meter per second. A woman rides a bicycle with a speed of 10 meter per second in the north to south direction. What is the direction in which she should hold her umbrella? So the described situation is shown in the figure. Here Vc is the velocity of the cyclist. So this is the north and south direction. The cyclist is moving from north to south, so Vc is the direction, velocity of the cyclist. Again, Vr is the velocity of the rain. Vr is the velocity of the rain. Now in order to protect herself from rain, the woman must hold her umbrella in the direction of the relative velocity v of the rain with respect to So here you have to understand what is the relative velocity here. So the relative velocity v will be this one. So we can write v is equal to vx and negative of Vy, because this point is negative of Vy. So if we write, the coordinate axis will be Vx and minus Vy, because this is minus this side. This point is minus Vy, and this my so we can write the velocity as Vx is equal to 30 minus Vy is equal to minus 10, that is Vx minus 30 minus 10, that is 20 meter per second, and tan theta is equal to Vy by Vx. Therefore, to find out the direction, we have to find the tan theta. So Vy is equal to 10, Vx is equal to 30, 10 inverse 1 by 3, theta is equal to 10 inverse 1 by 3. Now hence the woman must hold the umbrella towards the south of at an angle nearly 18 with the vertical. Now let us solve 4.13. A man can swim with a speed 4 kilometers per hour in still water. How long does he take to cross a river 1 kilometer wide if the river flows steadily at 3 kilometers per hour and he makes his stroke normal to the river current? How far down the river does he go when he reaches the bank? Now, in this case, speed of the man Vm is equal to 4 kilometer per hour. So first sentence is clear. Width of the river is 1 kilometer. This is also pretty simple. Time taken to cross the river is equal to distance upon speed, that is width of the river upon speed of the river. So width of the river is 1 kilometer. We have put 1. Speed of the river is 4 kilometer per hour. We have kept 4. So 1 upon 4 hour. Convert this into minute. So multiply by 60. That is 15 minute. Now speed of the river Vr is equal to 3 kilometer per hour. Is equal to 3 kilometer per hour. Now distance covered with flow of river is equal to Vr into T. That is Vr is 3 into T is 1 by 4, which is equal to 3 upon 4 kilometer. Again we convert it into meter, will multiply by 1000. So 3 by 4 into 1000, that is 370 meter. Now 4.14. In a harbor, wind is blowing at a speed. So let us mark the question first. In a harbor, wind is blowing at a speed of 72 km per hour and the flag on the mast of the boat encroached in the harbor flutters along northeast direction. If the boat starts moving at a speed of 51 km per hour to the north, what is the direction of the flag on the mast of the boat? Velocity of the boat Vb is equal to 51 km per hour. Velocity of the wind is equal to 72 km per hour, which are given in the sum. Now, the flag is fluttering in the northeast direction. It shows the wind is blowing towards the northeast direction. When the ship begins sailing towards north, the flag will move along the direction of the relative velocity. V VWP of the wind with respect to boat. Angle between VW, that angle between VW and minus VB is equal to 90 plus 45. 10 beta is equal to 51 sine 90 plus 45 upon 72 plus 51 cos 90 plus 45, which is again equal to 51 sine 45 upon 72 plus 51 minus cos 45, which is again equal to 51 into 1 by root 2 upon 72 minus 51 up into 1 by root 2. Now, upon solving, we got 51 upon 72 root 2 minus 51 is equal to 51 upon 72 into root 2's values. We will put 1.414 minus 51. So till here it is clear now. Now 51 upon, on solving this, the denominator we get 50.800. Now beta is equal to 10 inverse. Upon solving this thing, we got 1.0038, which is therefore beta is equal to 45.11. Angle with respect to the east direction is equal to 45.11 minus 45, that is 0.11 degree. Hence the flag will flutter almost due to the east. Almost due to the east. Now we'll do 4.15. The ceiling of a long hall is 25-meter high. What is the maximum horizontal distance that a ball throw with a speed of 40 meter per second can go without hitting the ceiling of the hall? So the speed of the ball is equal to u is equal to 40 meter per second. Maximum height 25 meter per second. The projectile motion, in projectile motion, the maximum height reached by the body projected at an angle theta is given by the relation h is equal to e square sine square theta upon 2g. Now 25 is equal to 40 square sine square 2 upon 2 into 9.8. Now sine square theta is equal to 0.30625. Sine theta is equal to root of 0.30625, which is equal to 0.55234. Now theta is equal to sine inverse 0.5534 and theta is equal to 33.60. Now horizontal range r is equal to e square sine 2 theta upon z. Therefore, u, put the value of u, theta and g, we get 40 square sine 2 into 33.60 upon 9.8, which is equal to 1600 into sine 67.2 9.8, which is equal to 1600 into 0.922 upon 98, which is equal to 150.53 meter. Now 4.16. A cricketer can throw a ball to a maximum horizontal distance of 100 meter. How much high above the ground can the cricketer throw the same ball? So maximum horizontal distance r is equal to 100 meter. Clear? The cricketer will only be able to throw the ball to the maximum horizontal distance when the angle of the projectile is 45 degree. That is theta is equal to 45 degree. The horizontal range of for a projectile projection velocity v is given by the relation r is equal to u square sine 2 theta g. Now we can write 100 instead of r we can put 100, instead of theta we can put 45 degrees. So we get an equation 100 is equal to e square upon g sine 90 degree. E square upon g is equal to 100 degree. This is equation 1. Now the ball will achieve the maximum height when it is thrown vertically upward. For such motion, the final velocity v is 0 at maximum height h. Acceleration a is equal to minus g. Using the third equation of motion, we got v square minus c square is equal to minus 2gh. H is equal to half u square upon g, that is half into 100, that is 50 m. Now we'll do question number 4.17. A stone tied to the end of the string 80 centimeter long is reeled in a horizontal circle with a constant speed. If the stone makes 14 revolutions in 25 seconds, what is the magnitude and direction of the acceleration of the stone? So the solution is length of the string is 80 centimeter, that is 0.8 meter. Number of revolution is equal to 14. Time taken is equal to 25 seconds. Frequency mu is equal to number of revolution upon time taken, that is 14 upon 25 hertz. Angular frequency omega is equal to 2 pi mu is equal to 2 into 22 upon 7 into 14 upon 25, which is 88 upon 25 radian per second. Centripetal acceleration AC is equal to omega square r, which is equal to 88 upon 25 whole square into zero point 0.8. Till here it is done. Now the direction of the centripetal acceleration is always, so on solving we get 9.91 meter per second square. So the direction of the centripetal acceleration will be always directed along the string towards the center at all the points. So now we'll move to question number 4.18. An aircraft executes a horizontal loop of radius 1 kilometer with a steady speed of 900 km per hour. Compare its centripetal acceleration with acceleration due to gravity. So, here it is given that radius of the loop r is equal to 1 kilometer, that is 1000 meter. Speed of the aircraft v is equal to 900 kilometer per hour, that is 900 into, we have converted into meter per second, multiplied by 5 upon 18 is equal to 250 meter per second. Now centripetal acceleration AC is equal to v square upon r, that is 250 whole square upon 1000, that is 62.5 meter per second square. Acceleration due to gravity is 9.8 meter per second square. AC upon Z is equal to 62.5 upon 99.8, that is 6.38. AC is equal to 6.38 G. So centripetal acceleration is multiple of 6.38 and acceleration due to gravity. Read each statement below carefully. So we are doing 4.19 now. Read each statement below carefully and state with the reason if it is true or false. A. The net acceleration of a particle in circular motion is always along the radius of the circle towards the center. B. The velocity vector of a particle at a point is always along the tangent to the path of the particle at that point. C. The acceleration vector of a particle is uniform circular motion. In uniform circular motion, averaged over one cycle in is a null vector. So let us see. So the first statement is false. Let us see the reason why it is false. The net acceleration of a particle in circular motion is not always directed towards the radius of the circle towards the center. It happens only in case of uniform circular motion. Now, the second statement is true. Reason is at a point on the circular path, a particle appears to move tangentially to the circular path. Hence, the velocity vector of the particle is always along the tangent to that point. So this is the reason why the second statement is true. And third statement is also true because in uniform circular motion, the direction of the acceleration vector points towards the center of the circle. However, it constantly changes with time. The average of three vectors over the circle is null. Of the average vector of these vector over the circle is a null vector. Now 4.20, the position vector of a particle is given by r is equal to 3t I minus 2t square j plus 4k m. M is meter, where t is in second and the coefficients have a proper units for r to be in meters. A. Find v and a of the particle. B. What is the magnitude and direction of the velocity of a particle at t is equal to 2 seconds. Now the position vector of the particle is given by r is equal to 3t I minus 2t square j plus 4k. It is clear now. Velocity v of a particle is given as v is equal to dr by dt, that is d. We'll put the equation, above equation, that is 3t I plus 2t square j plus 4k upon dt. So v is equal to, upon solving, we got v is equal to 3i 4j. Now acceleration a of the particle is given by a is equal to v dv by dt. Again, whatever we got for the value of v, we will again differentiate with respect to time. So we'll get we, a is equal to minus 4j, that is 8.54 meter per second. 69.45 below the axis. Now the B part. We have a velocity vector v is equal to 3I minus 4tj. At t is equal to 2 seconds, v is value will be converted to 3I minus 8j. The magnitude of velocity is given by under root 3 square plus minus 8 whole square, which is equal to under root 73 is equal to 8.54 meter per second. Direction theta is equal to tan inverse Vy by Vx is equal to tan inverse 8 by 3, that is tan inverse 2.667. Now we can see, so minus 69.49 is the answer. The negative sign indicates the direction of the velocity is below the x-axis. So, and this is the end of today's session. Please subscribe, like and share our channel. Please click on the subscribe button to support us, and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Thank you very much for watching our videos and supporting us.